Let me tell you something that may sound like a contradiction. The universe is 13.8 billion years old. Every physicist accepts that number. We have measured it with remarkable precision using the cosmic microwave background, the expansion rate of galaxies, the abundance of light elements, 13.8 billion years. It is one of the most well-established facts in all of science. And it is misleading, deeply, fundamentally, dangerously misleading, because that number implies something that physics does not truly support. It implies the universe began, that there was a moment, a first instant, a cosmic starting gun. And before that moment, there was nothing. No space, no time, no matter, no energy, nothing. And then bang, everything. I'm Leonard Susskind. I have spent my career working on the deepest problems in theoretical physics: string theory, black holes, quantum mechanics, cosmology. And after 50 years of thinking about these things, I have reached a conclusion that many find unsettling. The universe has no beginning. Not in the sense you imagine beginnings. Not like a movie has a first frame or a book has a first page. The Big Bang is real. The evidence for it is overwhelming. But the Big Bang is not what you think it is. It is not a beginning. It is not a creation event. It is not the moment when something emerged from nothing. And the reason I can state this with confidence is that the physics, the actual mathematics of general relativity and quantum mechanics reveals something far stranger than a simple beginning. Let me explain why. And I will be careful, because the ideas are subtle and the implications are enormous. Start with what we truly know. We know the universe is expanding. Edwin Hubble discovered this in 1929. Galaxies are moving apart from one another. The farther away a galaxy is, the faster it is receding. This is not because galaxies are flying through space like shrapnel from an explosion. Space itself is expanding. The fabric of the universe is stretching. Now, if the universe is expanding today, it must have been smaller yesterday and smaller the day before. Run the clock backward, and the universe becomes denser, hotter, more compressed. Keep running it backward, and you reach a point where all the matter and energy in the observable universe was packed into an unimaginably small, unimaginably hot, unimaginably dense state. That is the Big Bang. That is what cosmologists mean when they speak of the universe's beginning, a state of extreme density and temperature roughly 13.8 billion years ago. But here is what they do not tell you in popular science books. When you run the equations of general relativity backward all the way back, you encounter a singularity, a point where the mathematics breaks down entirely. The density becomes infinite. The temperature becomes infinite. The curvature of space-time becomes infinite. And in physics, whenever your equations yield infinity, it means your theory has failed. It does not mean something physical has become infinite. It means your mathematical description is no longer valid. Think of it like this. Imagine you are using a map to navigate a city. The map works perfectly for streets, buildings, and parks. But at the edge of the map, the streets simply stop. Does that mean the world ends at the edge of the map? Of course not. It means your map does not cover that territory. The singularity at the Big Bang is the edge of our map. General relativity, Einstein's beautiful theory of gravity and space-time, works brilliantly for describing the universe from a fraction of a second after the Big Bang all the way to today. But at the singularity itself, at that supposed first moment, the theory fails. It cannot describe what happened. It cannot even tell us if what happened is a meaningful question. This is not a minor technical issue. This is the theory telling us that the concept of a beginning, a first moment of time, may not make sense. The singularity is not a moment in time. It is the place where the concept of time itself becomes undefined. And this is where things become really interesting, because in the 1980s, two physicists proposed an idea that totally changes how we think about the origin of the universe. James Hartle, a brilliant physicist at UC Santa Barbara, and Stephen Hawking. Together, they developed what is called the no-boundary proposal. And it is one of the most elegant and unsettling ideas in all of cosmology. The no-boundary proposal says this: the universe has no boundary, no edge, no beginning, no first moment. Time does not start at the Big Bang. Instead, as you go backward in time toward the Big Bang, something extraordinary occurs. Time slowly transforms into space. Let me say that again, because it is one of the most mind-bending ideas in physics. As you approach what you thought was the beginning, the direction we call time smoothly becomes another spatial direction. There is no sharp boundary. There is no wall. There is no first moment. Time simply fades out and becomes space. Think of a globe, the surface of the Earth. Start at the equator and walk north. You can keep walking north for a long time, but eventually you reach the North Pole. And at the North Pole, northness does not suddenly end. There is no edge. There is no wall. There is no boundary. Northness simply stops being a meaningful direction. You cannot go further north than the North Pole, but not because something is blocking you. It is because north has ceased to be a direction at that point. Hartle and Hawking are saying that time does the same thing at the Big Bang. You can ask what happened 1 second after the Big Bang. You can ask what happened a millionth of a second after. You can even ask what happened at incredibly tiny fractions of a second. But you cannot ask what happened before the Big Bang, because there is no before. Not because something prevents you from going there, but because the direction before has ceased to exist. Time has rounded off into space like the surface of a sphere rounding off at the pole. There is no boundary. There is no edge. There is no beginning. Now, I know this sounds like philosophical wordplay, as if I am just redefining what beginning means to dodge the hard question. But it is not. It is a precise mathematical statement about the geometry of space-time, and it comes directly from applying quantum mechanics to the entire universe. Here is the key physics. In quantum mechanics, we do not describe particles as having definite positions and trajectories. We describe them with wave functions, probability amplitudes that encode all possible states. The wave function of a particle tells you the probability of finding it in various configurations. Hartle and Hawking applied the same logic to the universe itself. They wrote down a wave function for the entire cosmos, not a wave function for a particle in a box or an electron in an atom, a wave function for the universe, the wave function of the universe. Think about how audacious that is. They are treating the entire universe as a quantum system and asking what is the probability of finding it in various configurations. What is the probability of getting a universe that looks like ours with galaxies and stars and planets and people? And when you compute this wave function using the path integral formulation, Feynman's approach to quantum mechanics applied to gravity, something remarkable happens. The sum over all possible histories of the universe, all possible geometries of space-time, naturally yields a universe with no boundary. The mathematics does not require you to specify initial conditions. It does not require you to state what the universe was like at time zero. There is no time zero. The calculation is self-contained, complete, needing no external input. This is radically different from how we normally do physics. Normally, you specify initial conditions, the state of the system at some starting time, and then you use the laws of physics to evolve the system forward. Where was the ball at time zero? What was its velocity? Then Newton's laws tell you where it will be at any future time. But with the no-boundary proposal, there are no initial conditions. The universe does not need initial conditions because it has no initial moment. The geometry of space-time is closed and complete, like the surface of a sphere. You do not need to specify what happens at the edge of a sphere because a sphere has no edge. Now this raises an immediate and deep question. If the universe has no beginning, what caused it? What brought it into existence? And the answer that I think physics is pointing toward is that this question may not have an answer because it may not be a well-formed question. We are so used to thinking in terms of cause and effect. Everything has a cause. Something must have caused the universe. But causation requires time. A cause must precede its effect. And if time itself is part of the structure that needs explaining, if time is a feature of the universe rather than a backdrop against which the universe unfolds, then asking what caused the universe is like asking what is north of the North Pole. The question assumes a framework that does not apply. This is not a cop-out. This is not avoiding the question. This is recognizing that some questions, perfectly sensible sounding questions, rest on assumptions that turn out to be false. Before Einstein, everyone assumed time was absolute. It was not. Before quantum mechanics, everyone assumed particles had definite positions. They do not. And before Hartle-Hawking, everyone assumed the universe had a beginning. It might not. Let me dig deeper into this because there is another layer that most people never hear about: eternal inflation. In the standard cosmological model, the universe went through a period of incredibly rapid expansion called inflation in the first tiny fraction of a second. During inflation, the universe expanded exponentially, doubling in size again and again in an unimaginably short time. This explains several features of the universe that would otherwise be mysterious. Why the universe is so flat, so uniform, so large. Inflation was proposed by Alan Guth in 1980, and it is now a standard part of cosmology, well supported by observations of the cosmic microwave background. But here is the thing about inflation that changes everything. In most models, inflation does not stop everywhere at the same time. Some regions of space stop inflating and become normal universes like ours. But the space between those regions keeps inflating, expanding exponentially, creating more space, which creates more regions where inflation ends, which creates more normal universes. This process called eternal inflation never stops. It has been going on forever, not just for 13.8 billion years, and it will continue forever. New universes are constantly being born from the inflating space, like bubbles forming in a pot of endlessly boiling water. Our observable universe, everything we can see, all the galaxies, all the stars, the cosmic microwave background, all of it is just one bubble in an infinite sea of bubbles. Our Big Bang was not the beginning of everything. It was the moment when our particular bubble nucleated from the eternally inflating space. Other bubbles have their own Big Bangs, their own 13.8 billion years, their own galaxies and stars, and maybe even their own observers looking up at their own skies and wondering where everything came from. In this picture, the universe as a whole, the entire eternally inflating multiverse, has no beginning and no end. It has always been inflating, always been producing bubbles, always been creating new pocket universes. Our Big Bang is a local event, not a global one, a birth in an eternal family, not the birth of everything. Now, I have spent a significant part of my career working on the string theory landscape, which connects to this picture in a deep way. String theory predicts an enormous number of possible vacuum states, different configurations of the extra dimensions, different values of the physical constants, maybe 10 to the 500 different possibilities. Eternal inflation, if correct, would populate all of these vacuum states. Different bubbles would have different physics, different values of the fine structure constant, different particle masses, different forces. Most of these universes would be sterile, hostile, to complexity in life. But some, including ours, would have just the right conditions for stars, chemistry, biology, and consciousness. This is not speculation in a pejorative sense. It is a logical consequence of well-established physics combined with reasonable theoretical extrapolations, and it paints a picture of reality that is vastly larger, older, and more complex than anything our ancestors could have imagined. But let me come back to the central question. Does the universe have a beginning? In the no-boundary picture, our particular universe, our bubble, has something that looks like a beginning from the inside. We see the cosmic microwave background. We measure 13.8 billion years. We see the universe expanding and cooling. All of this is consistent with a hot, dense state in the distant past. But that hot, dense state is not a beginning in any fundamental sense. It is a transition, a phase change, a moment when our region of space-time changed character from exponentially inflating to slowly expanding. Before our Big Bang, if before even means anything, there was inflating space. Before that, more inflating space. And the geometry of the inflating region may have no boundary, no edge, no first moment, just as Hartle and Hawking proposed. There is a beautiful analogy I like to use. Think about the real number line. The numbers go from negative infinity to positive infinity. There is no beginning, no end, no first number. Now imagine you are a creature who lives on the positive real numbers. You can count backward 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then what? 0. But 0 is not nothing. It is a perfectly good number, and the negative numbers are on the other side of it. From your perspective, on the positive side, everything started at 0. Your world has a boundary. But from the broader perspective, 0 is just a point on a line that extends infinitely in both directions. The Big Bang might be like 0 on the number line. A special point, yes, a point where things change character, but not a beginning, not an edge, not a creation event, just a marker in a much larger structure that extends beyond our ability to see. Let me address the elephant in the room, the theological elephant. For centuries, the idea that the universe had a beginning was seen as evidence for a creator. If the universe began, something must have started it. Someone must have started it. The Big Bang seemed to confirm this. Even Pope Pius XI declared that the Big Bang was consistent with the Genesis account of creation. But if the universe has no beginning, if time itself rounds off smoothly with no first moment, then the argument from a beginning loses its force. There is nothing to start, no moment of creation, no first cause needed. I want to be clear. Physics does not disprove the existence of a creator. Physics cannot address that question one way or another. But physics does undermine one specific argument for a creator. The argument that the universe must have had a cause because it had a beginning. If it has no beginning, that argument does not apply. Now, there is a subtlety here that I think is important. Even if the universe has no beginning, it still exists. And you might reasonably ask, why does it exist? Why is there something rather than nothing? This is perhaps the deepest question in all of philosophy, and I am honestly not sure physics can answer it. The no-boundary proposal explains how the universe could exist without a beginning. But it does not explain why there is a universe at all. Maybe that question has an answer. Maybe it does not. Maybe it is like asking why mathematics works. There might not be a deeper explanation. It might just be a brute fact about reality. But I can tell you what I think as a physicist who has spent decades thinking about these things. I think the question, why is there something rather than nothing, may be based on a false dichotomy. It assumes that nothing is the default state and something requires an explanation. But maybe nothing is not possible. Maybe the absence of existence is not a coherent state. Maybe reality, existence, The universe, whatever you want to call it, is necessary rather than contingent. Maybe the question answers itself, or maybe not. I do not know. And anyone who claims to know is selling you something. Let me talk about another aspect of this that I find especially fascinating. The arrow of time. If the universe has no beginning, why does time seem to have a direction? Why do we remember the past and not the future? Why does entropy increase? Why do eggs break and never unbreak? In the standard picture, the arrow of time comes from the initial conditions of the universe. The Big Bang was a state of extremely low entropy. And because entropy can only increase from a low starting point, we get the thermodynamic arrow of time. The past is the direction of lower entropy. The future is the direction of higher entropy. But if the universe has no beginning, where does the low entropy come from? The no boundary proposal actually has an elegant answer to this. When you compute the wave function of the universe using the Hartle-Hawking prescription, it naturally predicts that the universe begins in a low entropy state. Not because someone set it up that way, not because of initial conditions, but because the no boundary geometry naturally selects for low entropy configurations. This is one of the most remarkable features of the proposal. It explains the arrow of time without needing to invoke any special initial conditions. The arrow of time emerges from the geometry of space-time itself, from the fact that time rounds off into space at what we mistakenly call the beginning. I should be honest with you about the current state of this debate because it is far from settled. The no boundary proposal is not universally accepted among cosmologists. It has strong supporters and strong critics. Some researchers like Neil Turok and his collaborators have argued that the Hartle-Hawking calculation, when done carefully, actually does not give the results Hawking claimed. They argue that the saddle points of the path integral lead to unstable or physically unacceptable solutions. Others, like James Hartle himself and his collaborators, have defended the proposal and refined it over the decades. The debate is technical and ongoing, and I am not going to pretend it is resolved. There are also alternative models of a beginningless universe. The cyclic model proposed by Paul Steinhardt and Neil Turok suggests the universe goes through infinite cycles of big bangs and big crunches. Each cycle is preceded by a previous cycle and followed by a new one. No beginning, no end, just eternal repetition with variation. Roger Penrose has his own version called conformal cyclic cosmology, where the heat death of one eon becomes the Big Bang of the next through a conformal rescaling of space-time. Different details, same basic idea, the universe is eternal. Then there are models based on quantum gravity loop, quantum gravity in particular, that replace the Big Bang singularity with a big bounce. In these models, the universe was contracting before our Big Bang reached a minimum size and then bounced into the expansion we observe today. There was no singularity, no infinite density, no breakdown of physics, just a smooth transition from contraction to expansion. What happened before the bounce? Another phase of the universe's existence. And before that, we do not know. Maybe the bounces go back forever. All of these models share one thing in common. They reject the idea that the universe popped into existence from nothing at a definite moment in time. They all say, in their different ways, that the Big Bang was not a beginning. It was a transition, a phase, a marker in a larger story that may have no first chapter. Now, here's what I find most profound about all of this. It changes how we think about existence itself. We are used to thinking of existence as something that starts. You were born, you will die. The book starts on page 1 and ends on the last page. Every story has a beginning, but the universe might not be a story. It might be a structure. A self-contained 4-dimensional or maybe 10-dimensional or perhaps infinite dimensional structure that simply is not created, not started, not designed, just existing like a mathematical truth. Nobody created the fact that 2 + 2 = 4. It does not have a beginning. It does not have a cause. It is not contingent on anything. It just is. The universe might be like that. A necessary structure that could not exist. A mathematical reality that contains as one of its features regions that look like big bangs and expanding universes and galaxies and planets and creatures who wonder where it all came from. I know this is hard to wrap your head around. It was hard for me too, and I have been thinking about it for decades. Our brains evolved to understand beginnings and endings, birth and death, sunrise and sunset. Our entire cognitive framework is built around the idea that things start and things stop. But the universe might not respect our cognitive framework. It might not have a beginning any more than the surface of a sphere has an edge. It might not have a first moment any more than the real number line has a first number. The beginning might be an illusion, a feature of our limited perspective, not a feature of reality. Let me tell you what 50 years of thinking about cosmology has taught me. The universe is stranger than we can imagine, stranger than we can probably ever imagine. Every time we think we have understood its fundamental nature, it surprises us. We thought space was empty. It was not. We thought time was absolute. It was not. We thought the universe was static. It was not. We thought the expansion was slowing down. It was not. It was accelerating. And we thought the universe had a beginning, a moment of creation, a first instant when everything came into being. But the physics, the mathematics, the equations we trust more than our intuitions. They point somewhere else. They point to a universe with no boundary, no edge, no beginning. A universe that simply is complete and self-contained. A closed geometry in which the question, what came before, does not have an answer, because before does not lead anywhere. It is like asking what is south of the South Pole. The question contains its own impossibility. Could I be wrong? Absolutely. This is frontier physics. We do not have a complete theory of quantum gravity. We do not know which, if any, of these models is correct. Maybe the universe does have a sharp beginning that we simply have not understood yet. Maybe there really was a first moment, a cosmic T equals 0, a literal starting point. But the trend of physics over the last century has been relentlessly in one direction. Away from sharp boundaries, away from absolute beginnings, away from edges and singularities and first moments, toward smoothness, toward completeness, toward structures that are self-contained and self-consistent, needing no external input, no starting push, no prime mover. I think the universe has no beginning. Not because I want it to be that way, not because it serves any philosophical agenda, but because that is where the physics points. That 13.8 billion years you keep hearing about, it is real. But it measures the time since our local region of space-time changed from one phase to another. It marks a transition, not a creation, a doorway, not a starting line. Beyond that doorway, there might be an eternity we can never access, but that exists nonetheless. An infinity of inflating space, spawning universes without end, governed by physics we are only beginning to understand. You thought the universe began. You thought there was a first moment, a cosmic birthday, a day when everything started. Physics says otherwise. Physics says the universe might be eternal, boundaryless, complete, a structure without edges, a reality without a first page. And that to me is far more beautiful and far more terrifying than any creation story humanity has ever told. Thank you for listening. Go outside tonight. Look up at the stars and remember the light reaching your eyes has traveled for thousands of years. But the universe that produced those stars, the fabric of space-time that holds them in place, that might have no beginning at all. It might just be always and forever without start, without cause, without explanation. Just reality being itself.